Good day. Welcome to our discussion on Week 7 lesson titled Qualitative Characteristics of Images Formed by Lenses. Be sure that you have your notebooks with you so that you will be able to answer questions and take down notes as we go on with our discussion. Our objective is to apply ray diagramming techniques in describing the characteristics and positions of images formed by lenses. Specifically, we need to differentiate diverging and converging lens, construct ray diagrams to locate the image formed by thin lens at different positions of the object from the lens, and demonstrate appreciation of the basic information about lenses and how they work. For the first activity, you will write your answer in your notebook as an e-portfolio entry. Feel free to pause the video in order to write your answers. Let's start with 4 picks 1 word. Identify the term associated with the given pictures. First word. Answer. Mirror. Second word. Answer. Lens. Third word. Answer. Reflection. Fourth word. Answer. Refraction. These terms are important in discussing the similarities and differences between mirrors and lenses. But how are lenses different from mirrors? Mirrors reflect light. There are two types of curved mirror, concave and convex. When parallel light rays strike a concave mirror, the reflected rays meet at a common point known as the real focus. When parallel light rays strike a convex mirror, the reflected rays are scattered. But when you extend the reflected rays behind the mirror, they will meet at a common point called the virtual focus. Lenses, on the other hand, refract light. There are two types of lens, double or biconcave and double or biconvex. When parallel light rays strike a double concave lens, the light rays refract towards the thicker part of the lens. That's why the refracted rays scatter or move away from each other, while a double convex lens allows light rays, parallel light rays, to refract towards the thicker part of the lens, which is the center. That's why they meet at a common point known as the real focus. Observe how the light rays behave as they enter the lens. In describing lenses, it is important that we know the difference between the focal point and the focal length. When parallel light rays strike a lens, specifically a double convex lens, the refracted rays refract or bend towards the thicker part of the lens, which is the center, and meet at a common point called the real focus. Focus is the point where the refracted rays meet. It is also called the focal point. Now, the distance between the lens and the focal point is called the focal length. Take note that the point behind the lens where the refracted rays meet is called the real focus and has a symbol capital letter F. Twice the focal length is where 2F is located. The point in front of the lens is called the virtual focus or F prime. Twice the focal length is the point called 2F prime. How does a convex lens produce an image? Suppose the candle on the left is the object. When light rays leave the object and travels parallel to the principal axis, it will be refracted towards the focal point. When the light coming from the object passes through the center of the lens, it will not be refracted, it will just travel in a straight line. When a light ray coming from the object passes through the virtual focus and enters the convex lens, it will be refracted parallel to the principal axis. The point where the three refracted rays meet is where the image is formed. Another ray diagram is demonstrated on the screen, where the object is located between the focal point and the lens. You will see that the different rays, ray 1, ray 2, and ray 3 produce this image, which is larger and upright. Now observe how the light rays behave as they enter this type of lens. See the difference between the first lens and this lens in terms of how the rays refract. Double concave lens is also called diverging or negative lens. Diverging because when parallel light rays strike the lens, the refracted rays scatter. That's why it is called a diverging lens. And when you extend the refracted rays in front of the lens, they will meet at a common point called the virtual focus or the virtual focal point. The ray diagram for a concave lens is similar to a convex lens. The point behind the lens is called the real focus or F. Twice the focal length is the point called 2F. In front of the lens, where the imaginary refracted rays meet, or the extension of the refracted rays meet is called the virtual focus or virtual focal point, labeled F prime. Twice the focal length is where 2F prime is located. This is an example of a ray diagram for a diverging lens. Let us describe each ray in the ray diagram for a diverging or concave lens. Suppose we place an object on the left side of the lens. Ray 1, coming from the object, traveling in a straight line parallel to the principal axis, will be refracted towards the thicker side of the lens. When you extend the refracted rays, it will pass through the virtual focal point. Ray 2 will pass through the real focus and refracted parallel to the principal axis. When you extend the refracted rays in front of the lens, you will see that they meet, the refracted rays meet at a common point. Now, to verify if this is the point of intersection of the refracted rays, we use ray 3. Ray 3 is the light ray coming from the object, passing through the center of the lens, and it will not be refracted, it will travel in a straight line. The point where the three rays intersect is where the image is formed. For the next task, you will write your answers in your notebook as an e-portfolio entry. Again, feel free to pause the video in order to write your answers. By applying ray diagramming techniques, perform learning task 3 by completing the table for convex lens. You may use this as a guide in answering the learning task 3 for convex lens. Please refer to the given table in checking your answers for learning task number 3 for convex lens. Now, let us have the learning task number 3 for concave lens. You may use this as a guide in doing the learning task 3 for concave lens. Please check your answer using this table. Let us remember the key points of this week's lesson. Refraction explains how lenses work. There are two types of lenses, converging and diverging. Using ray diagramming techniques, images of lenses can be located. For the assimilation part, please write your answers in your notebook to be recorded as an e-portfolio entry. Identify the size, type, orientation, and location of the image formed when you place the object between the virtual focal point and the lens for a magnifying glass. Let us check your work. When you place the object between the virtual focal point and the lens, you will produce an image that is enlarged, virtual, upright, and located in front of the lens. Now, let us identify the size, type, orientation, and location of the image formed when you place the object at 2F prime for a Xerox machine. To check our work, when you place the object at 2F prime, you will produce an image that is same, real, inverted, and located at 2F. Now, let us have the size, type, orientation, and location of the image formed by the human eye when the object is beyond 2f prime. Let us check your answer. For an object that is placed beyond 2f prime, the image that is produced is smaller, real, inverted, and located between f and 2f. Each characteristic of the image is worth 1 point. So all in all, the 3 optical instruments given in this activity will get 12 points. I have here examples of optical instruments that utilize lenses, which are very useful in our different fields of study. We will be discussing them in detail when we have our lesson next week on optical instruments. Before we end our session, always remember, let us be like convex lens. Let us magnify only the good and positive traits of the people around us. Good day and God bless.